This is problem 78 from chapter 6 in the Walker book. In this case, a student wants to find the coefficients of static friction and kinetic friction between a box and a plank. And so she's gradually raising that plank and increasing the degrees until the box starts to slip. And so then we're going to switch from static friction to kinetic friction as it slides down the plank. So in part A, we're going to try to use just the degrees actually to find the coefficient of static friction, which is pretty cool. And that's all you need to find it. As we draw our picture here, on the free body diagram, we're going to draw we've got the crate here on the ramp. This is 30 degrees. And let's imagine we have the box here. Okay, so we've got weight, which is going to go straight down, FG. And then if we're imagining the moment right before it slides, where it's still not accelerating, but it is just about to move, then we can imagine for A that acceleration is still 0, but which means that F net is 0 as well. But F static friction is at its max. So then I'm going to show on my diagram that I've got, if I was going to draw the components of gravity here, I would show that part of this gravity comes down, and then down in what I'm going to call the y prime axis, and then part of gravity comes like down the ramp, which I'm calling the x prime axis. So that would be what would cause the box to slide down the ramp. But what's keeping that from happening right now is this force of F static, or static friction, and that would be canceling exactly with my component of gravity that is along the ramp direction. And then don't forget our normal force here. So that is canceling with the part of gravity that wants to pull the box sort of down through the ramp, but that's not happening. Let's see, it's 5 boxes on my picture, so 1, 2, 3, 4, 5. So I'm showing that here. Okay. Really, I'm just on an AP diagram, I would only show the 3 big forces here, the green solid Fn, the black solid Fs, and the red solid Fg. And I would not draw the components, but all of these forces are canceling. So if I want to look at my x and y prime directions, then I know that if I want to find mu k, then mu k would be the force of friction divided by the force of normal force. So I'm going to need to find those two. Sorry, I'm talking about mu s right now. We'll get to mu k later on, so let me fix that. Mu s is going to be the force of friction over the normal force. So let's go finding each one of these, and then we'll be able to solve for the coefficient. So let's start with, let's say, the x direction. So in the x prime direction, I guess I should call it, then I know the net force is 0, and therefore if I maybe call this the positive direction, I have fg comma x prime plus negative fs equals 0, which means those two magnitudes are equal. And I can tell, by the way, that this angle between the perpendicular to the ramp and FG is also 30. So then I'm saying that FG x prime is this one, and that is opposite of that angle. So I can take hypotenuse times sine of 30, and that would tell me what FS max is, which I'm going to need later. So this would be, to simplify a little bit further, this would be mg sine 30 degrees. Okay, I'll use that in a minute. And then in the y direction, also the forces are all canceling. This this crate or box is not accelerating down into the ramp, and it's not accelerating up into the air. So that means that the y prime portion of gravity, which I would usually say is down is negative, must be canceling with the normal force. So those magnitudes are the same. And therefore the normal force would be my hypotenuse times the adjacent, or sorry, I'm looking for the adjacent side. So to get that, I would take hypotenuse times cosine of 30, and just one more step to say this is mg cosine 30. So then when I go to solve for mu s, I go back up here, I said mu s would be the force of friction divided by the normal force. Well, now I have an expression for both of those. So when I write this out, I've got mg sine 30 over mg cosine 30. And what I end up getting, these mg's cancel out. Sine over cosine, I think, is tangent. So then when I do tangent 30 degrees, let's see here, I end up getting a decimal that represents the coefficient. Yeah, which is equal to 0.58 with no units. Okay. Then if I'm gonna do part B, I will use the same diagram, but this time I'm going to have less friction and it's going to accelerate down the ramp. So I'm running out of time. I want you to try that one. You would use these two pieces of information to solve for ax prime, and then write a new equation for f net x prime, okay, where now we've got Fk, and the net force is no longer 0. Now it's going to be mass times acceleration. So see if you can solve that one.